So today we have as a guest Benny. He's a senior technical architect at Jonah Group. While doing this work, Benny also helps to establish the Jonas AI Lab to expand into machine learning and deep learning business. I follow them on LinkedIn, and they are always hiring, so be sure you do the same. Fully aware of the blockchain impact on business, Benny has established a strong technical knowledge on Hyperledger and Ethereum by successfully designed and built systems for the medical health record and token exchange. He has a Bachelor of Science and a Master of Science in Computer Science from University of Guelph, where his master's thesis is on AI expert system technologies. Ben is constantly posting AI, machine learning, and deep learning topics on his blog, which is Cheung at github.io. You don't have to remember that. We'll post it in our next newsletter. So please let us know. Here you go. Let me turn this off.
So after the sci-fi talk from Peter, I don't think anything can match that kind of science fiction type of a topic. So I will try my best. I will try my best, and I will try to putting in some jokes so that compensating the sci-fi factor right here. And thank you for the opportunity. And this is something that is in our mind recently because we are actually doing enterprise system. And I heard the question that's saying, what is enterprise system? It's just a big company that they need to facing public, so that they need to worry about all the privacy of the policy and everything. So our main business is in banking, finance, healthcare. So that's why this explainable AI problem is very important to us. And I will try to tell you what does it mean through this talk. So starting with a comic that it seems to be, we have a professor tonight, we have a student. So it's exactly when you go to a math exam, if you do something like this, I don't think you can actually getting through, right? And but in deep learning nowadays, it's a kind of, hey, it's a miracle happen, and then we be able to make a prediction. I don't think we can letting it through, especially for enterprise system. I always would like to starting with a philosophical quote. My favorite philosopher is Ludwig Wittgenstein. If you did not read him, do, because it actually helps in computer science, believe it or not. And he is actually a philosopher without a computer, but doing all the computer thinking. So from his philosophical investigation, to make the talk interesting, I need to bring in lion, because he is saying something like this: if a lion could speak, we could not understand him. Hey, and you may think that's impossible, because if the lion can speak in English, I have to understand what he is talking about. But it's not true, because this is two completely different intelligent beings, and they are coming from two completely different cultures. If lion can speak, unlikely that you will be able to understand what he is talking about. And it's not very far-fetched. Just imagine that you're sitting in a lunch table with two colleagues that are playing World of Warcraft, and they start to talking to each other about the World of Warcraft that you never played before. They are speaking in English. You have no way to understand what they are talking about. So the language itself is actually a culture. Why is that important to us right here? Because AI is very much like lion to us. And in the beginning, deep learning trying to explain itself is getting pretty funny, because a boy is holding a baseball bat. It's funny. A cat is actually sitting on top of a remote control, which is not a cat, right? And the most funny thing is a woman holding a teddy bear in front of a mirror. Well, and this is 2015. If in 2015 we do explainable AI in this way, we find it funny. But if you take a look at it today, your feeling is totally different, because Uber car is actually killing a pedestrian. It did not stop. And then Amazon is using a secret AI to do recruiting, but it shows that it's biased against women. So now become less funny, and we can imagine why, because it's actually affecting our life, and there's more and more AI system was being deployed. So that's why it become a major problem. And you can imagine in terms of the enterprise, right? Uber, Amazon themselves is an enterprise system. If they deploy AI, getting this kind of perplexity is going to be very damaging for a long time. And we want to try to avoid that. So we are talking about enterprise, why they are so uptight about explainable AI. Of course, they want to optimize the algorithm, whatever machine learning that they do, they want to optimize it. Not until you be able to understand what is doing that you can optimize. Of course, they want to continue maintain and retain. And at the end, they need to actually putting it into public. They need to have a lot of accountability and also regulation that they need to follow. In this case, later on in my presentation, that I will go into talk about regulation a little bit more, and I will give you a healthcare example on regulation. But in some sense, that this whole life cycle that an enterprise system will need to taking care of explainability. Well, and but before we are getting into the actual explainability, first of all, we need to understand a little bit about there's two different intelligence scale right here: the human intelligence scale and then AI intelligence scale. So of course, at the end, we would like them to talk to each other, like how can you come to this decision? Hopefully, you'll be able to make the connections. In human intelligence scale, that is very famous, that we are actually multifaceted, and we have many different types of intelligence that is very well known. And even though most of the computer science that we emphasize in logical and mathematical training, but that's actually show intelligence is actually more than just logical and mathematical. And I'm not an expert in psychology or human intelligence, so I stop right here, that just saying human is actually multifaceted. But when we take a look at AI, AI itself is very multifaceted too. And I like the DARPA, they actually spending a lot of money in explainable AI, that they coming up with this 4 intelligence scale to measure artificial intelligence: perceiving, learning, abstracting, and reasoning. So we will go into take a look at AI history a little bit. So they kind of dividing the AI into 3 waves. And we will see how each wave is actually improving on this artificial intelligence scale. And this is going to be very important because we want to design system accordingly. The first wave of AI, which I'm coming from, the expert system era, is a long time ago. And after expert system, there's the AI winter. So we don't get to practice AI at all, not until recently. So there's a long story. I save it until later to tell you the full story of the AI winter. But expert system is the first wave. So let me give you an example. The expert system is actually encoding human knowledge directly into the computer system so that you can follow rules to actually do some prediction. So let's say we want to predict the number from 0 to 9. So we actually encode the stroke sequence for that number so that you'll be able to recognize whenever you do another stroke, that you'll be able to recognize what is going on. But it's very specific, very narrow, very brittle. So for example, the 4, that you can see the 4 can be written in a different way. Then if you don't upgrade your expert system rules, then you cannot recognize it. So the first wave, you can say the perceiving is pretty bad, and absolutely have no learning, abstracting, there's nothing. But it's very strong and as reasoning, because we actually encoding the symbolic reasoning directly into the AI system so that you be able to do human reasoning very well. So whatever that you do, it explains very well too, because it's exactly how human was being designed. When I'm talking about some old AI technology, doesn't mean it's old means bad. Sometimes depends on the situation. Old technology is still relevant today. And actually, many systems that is still running with expert system. Like if you do your text reasoning, that a TurboTax is all expert system was built into it. It's actually occur everywhere in the society. because of the bad name and people don't advertise, I'm using expert system. They have silently, they are calling it rule-based right now. Second wave, which is what happened today, is characterized by learning, okay? So in this case, that we give a whole bunch of example, like Sarah showed us, that we give example of the driving, then it coming out with a magical neural network. The bottom row is actually showing the final layer of the neural network, that what does it mean by recognizing those digits. And you can more or less recognize it, but it's very statistical, probabilistic in some sense. And this wave that we all experience today is so successful because you'd be able to perceive the environment, you'd be able to do learning. But in terms of abstracting and reasoning, that is still lacking, right? Like the first picture about the comic, that's saying magic happened and then make the prediction. Is acceptable in some area, but when you're facing public with regulation, that is totally not acceptable. So I'm coming from the old era and then seeing the current era, that I immediately think, is there a way to actually make both of them working together, right? So it's very natural, and I'm happy to find that DARPA actually producing the third wave of AI is actually trying to balance it out. How can they do that? So based on context. So the magical thing is still using the perceiving power and learning power of an example, but at the same time, they also integrating with the contextual information, such that it is not only based on statistics, it also based on the stroke sequence, so that they are actually being able to explain why certain character was being recognized, and it's actually increased the power of recognition. So this third wave is relatively new, and when you go in public and search for literature, it's a very few papers coming out, but it's more and more coming out that people actually build neural network coming along with contextual reasoning, so that it's more explainable. But today I'm not talking about making neural network better. I want to talk about explainability model. So at the end of the day, that we want explainable as a quality function to maximize the quality of our explanation, right? But there's many factors that's going to affect it. And I like to approach it in this way, because, rather than telling you all of the explainability technique that you'll be able to read online right now. I want to give you a framework, so that once you understand this framework, whatever technique coming in, that you'll be able to classify them, and you know exactly what that explainability is trying to do. So there's many factors affecting explanation. This is actually research coming from Google, and I like this research a lot. So I kind of repeat what they are saying, but at the same time I add in some of my understanding. The model matter. So if you have the green model, it's very easy to explain because it's linear. But in real world, usually the model is a little bit more complicated. And also we understand the accuracy and interpretability is going in reverse. Linear model is very easy to interpret, but usually it's less accurate. Neural network is very accurate, but at the same time it's very hard to interpret. So the model matter, okay? So you can see the equation, the model matter. Data matter. If you have clean data, of course it's very easy to explain. Very cleanly separate the red and green with a linear line, very easy to explain. But real world is a little bit more challenging and not always falling into the beautiful boundary. And also, this is only 2 dimensions, and we are talking about many dimensional data. So, so a data matter, what type of data that you have. Humans matter. Understandable, depends on the level of the human expertise. A no voice or a expert, you need to making them understand in a very different way. If things are traceable, it's much easier to understand too. Of course, when it's reasonable, following our symbolic reasoning, there's going to be much easier to explain. Task matter, and there's a local and global. and there's model specific and also model agnostic. So I'm going to give a little bit of explanation. So local explainability is when you have one single cat picture, and you'll be able to explain this is a cat by pointing out the highest firing neuron, which is the red area. Then it's local explanation, because you can explain this single cat picture, why it recognizes it as a cat. But in a more global explanation is after you get so many cats, the system start to being able to explain, because I get pointy ear and also furry hair, then it's a cat. So the explanation it become more global, more encompassing. There's also model-specific technique that the model itself have a built-in capability of explanation. Like linear regression model is linear, is very easy to explain, and also you can do the prediction. Decision tree is another example that the model also building with explanation. But most of the time, if the model cannot be explained directly within the model, that we build a parallel model, that the model do the prediction, yet the other parallel magic is going to do the explanation. This is a very common technique being applied for explainability, that model agnostic technique. At the end, that now we be able to classify any explainability model out there. So sometimes we just want to explaining about the data, doesn't have any model, so that we can just use visualization technique so that you can actually see the data. Human will be very easy to perceiving it. But most of the time that we are using the post-training explanation is we have a model that cannot be explained by itself, like deep learning, that we build a parallel model that are doing the explanation. Most of the technique like Lime, Sharp, belongs to this post-training explanation. But much I prefer is the building inherently interpretable model, is the model itself can explain. Very much like the rule-based system is like that, decision tree is very much like that. So now we be able to classify all of the technique. For us, we have a healthcare enterprise, and I'm going to give you an example. And the healthcare enterprise usually come in with big data with many different forms. So for example, they have a structured health record. The case description is going to be a natural language text. X-ray and CAT scan is an image. Echocardiogram, which is a video sequence. And also Dr. memos, maybe just in voice data. So they have many of these data. So we help them to build a machine learning pipeline using the traditional machine learning technique, deep learning technique, doing the evaluation. But of course, they have big data. We are talking about enterprise that we need to actually build a much more powerful deployment pipeline in such a way that a parallel computing can happen. At the end, the system itself is not going to live by itself. You need to be connecting up with the bigger system. So you need to be security system integration layer that we need to take in care. But after we understand the enterprise actually require explainable AI, then we are going to adding in interpretability in such a way that we have an explanation and also following the regulation. And I'm going to introduce a HIPAA rule explainability. So a HIPAA is very mouthful. It's Health Insurance Portability Accountability Act. And our client is in US, right? This is a US rule. It's actually governing how the medical health record was being shared between the practitioner. So they need to follow a set of rules. And I just give you an example of the rules. It's actually need a lawyer to really fully understand it, but I can briefly show it to you. It's actually about the use and disclosure of protected health information. You need to going through every single one of these sub-clauses, cross-reference section, and you check every single possibility to see whether the data is permitted to transmit or not permitted to transmit. So, and we do an analysis, and hopefully you cannot even read the tree that single rule it was being translated into. Let me zoom in a little bit. Yes, actually, you have the subsection, so on and on. Okay. And there's no point to explain it right here, but I just want to show you a complexity of a single rule is pretty daunting. So after doing the analysis, we use the backward training inference strategy so that we be able to producing a pretty useful, explainable rule-based system. Just like what I say, all technology doesn't mean bad, but when it's applied in the right place, which is good. So we translate Hebrew with Pollock. Anybody know Pollock right here? Yeah, so most likely we study in school, but actually Pollock is pretty powerful and useful. And not only me using it, is actually I'm following some other researcher. They are using Pollock. IBM is definitely using Pollock to do most of their rule processing. So all technology doesn't mean bad, but you need to find the right application. Right here, that I just show a section of the Pollock program. So when we run it, that we have full explainability coming out from the system. Now, at the end, that we have human and AI, they be able to talking with each other as long as we design system that let AI talking back to us, right? So now we can say if AI could speak, we could understand it. Hopefully I give you enough sense, but if you want to find more, and by the way, I will give the slide deck to Jericho, so you'll be able to subscribe to the newsletter, then you'll be able to download it. And this is coming from H2O, H2O, which is the AI framework, and they actually putting a whole department to do explainable AI. Guess why? Because they have many enterprise clients. They cannot get the AI system deployed until it becomes explainable. And there's a book. I don't think there's many books exist out there. This is such a thin book. I think you can download it online, called Introduction to Machine Learning Interpretability. That you can read all of the techniques that's available. But after my talk, that you're actually having a framework to understand every single technique. Hopefully this will help you. That's the end of my talk, and I'm working for Cheung Group, and I contribute a lot of AI and blockchain article on Cheung Group blog, and I run my own My Hack blog that I'm running for a couple of years right now. So I talk about all kinds of things, and this is all of my contact. So please connect, and I'd love to talk to you more. Okay, any questions?
Let me start with the other place first. Anybody? Any questions?
No questions. All right. It's so clear.
I thought I'll be the first woman to ask some question at least.
Yes.
So I work on applications to make them user-friendly.
Yes.
So more on the user experience side. I'm wondering if AI has any connection with user experience design, where a user can actually see the benefit of AI and understand what that means in actual while they're using an application.
Yes, there's definitely many learning systems. They are actually applying the AI rules. One of the obvious cases is they have the rules to actually assist the user at different level. Like what I say is depends on your user level. They provide explanation in a different way. So I see application in the learning system is actually applying AI. But in general, I'm not an expert in this area, so I cannot really tell you other than the thing that I see.
I really liked your presentation.
Thank you. Thank you. Yeah. Yes.
Hi, I have a question about the explainability of machine learning techniques. My question is, are they explainable, at all? Because can we really reach to that goal? I think technically, I think a lot of techniques in machine learning are designed in a way that make them very hard to explain, and also philosophically, you know, like humans, when we learn about to recognize, like kids learn to recognize cats and dogs, they don't know why they, you know, kids don't understand why they are dogs and cats. They just recognize it. So yeah, that's my question.
Yep.
Thanks.
So it's a big question, so I try to answer a small part of it, and unlikely that we'll be able to touch on even the philosophical question of how a kid actually get to learn the things about the world. So read a little bit of Ludwig Wittgenstein that I greatly recommend. But on the question is, can some of the deep learning model being able to explain? And take a look at the DARPA. DARPA actually spending billions of dollars. There's many research institute right now is actually trying to make deep learning model explainable. And they have various techniques, and I just mentioned one is like the cat. Now it's not just recognize the cat, it's actually giving the contextual information so that the deep learning model not only do the prediction, but at the same time, throughout the neural network that actually describing pointy ear and furry hair, so that it actually coming out with explanation why certain neurons get fired with a certain cat feature coming out. So, so it's happening, and the same thing with the self-driving is people also trying to produce model, make self-driving explainable. Because why do you turn left? Why do you not turn right? Why don't you hit this pedestrian? And this kind of thing that they are actually generating a model right now that go along in parallel, because a deep learning model is not fully explainable by itself, but it's actually running in parallel, getting to be explainable. So this is relatively new research area, and also it is the first interdisciplinary area that involves philosophy, sociology, and everybody, like linguistic, and you can imagine it's going to be a very active research area. So if you are interested, you should totally take a look at Explainable AI. All right.
Anybody else? Oh, there. But it was funny that you gave the example with the lion. I don't know if you can build a system to explain me what my daughters are telling me. I have no idea when I talk to them.
Hi, not 100% sure on this, but most AI models are about correlation, right? So how do you know, like with that Amazon example you use, how do you know that it's biased against women? Because you don't really know cause, right?
Yes, and actually this is one of the big questions for the explainable AI community. And actually explainable AI have come with many different names. It's called interpretable AI, transparent AI. There's many names. But if you go YouTube and search a little bit, and they actually try to build a model, especially detecting whether sex, woman or man, actually important for the network. It's not only predicting the results, but at the same time, for certain biases, they would like to train a network that is going along with the deep learning network in such a way that they know the prediction have nothing to do with sexual bias. So there's quite a few new research coming out, and just like what I say, it's a brand new area. People are very interested getting it explainable. Otherwise, enterprise system will not deploy machine learning. Yeah.
Okay, thank you very much.